transformation time. Digital transformation time.
I am Sergey Irisov. I've built the connected backbone for green aviation and nuclear. ALM, PLM, ERP, MES. In those worlds, if your systems don't agree, you can't certify. And if you overconnect them, you will build a tangled mess no small team can maintain. So I had to be surgical about where the connections go. Two promises. If you're a founder, you'll stop seeing integration as a giant IT project to buy. You'll start see it as a few high-value decisions about boundaries. If you're a tech lead, you'll get a clear way to decide which connections to build first and which to never build. And you'll see why the boundaries between systems matter as much as the links across them. Let me start by naming these four worlds. Most people can't even say them clearly. There are four worlds in most engineering companies. People throw the acronyms around: ALM, PLM, ERP, MES. But almost nobody states cleanly what each one owns. And you can't decide what to connect until you know that. So, plainly. First, ALM, Application Lifecycle Management. This is the world of requirements, often the software and systems engineering side too. What the product must do, how it's specified, verified, and validated. If your product has a software or complex behavior, this is where the what and the why live. Think of ALM as the world of intent and proof. Second, PLM, Product Lifecycle Management. This is the world of the design, the CAD, the EBOM, the configurations, the engineering changes. ALM owns what must it do, PLM owns what is it as engineered. This is the world of the design truth. Third, ERP, Enterprise Resource Planning. This is the business world, orders, purchasing, inventory, finance, suppliers, cost. ERP doesn't care how elegant your design is. It cares what it costs, what's in stock, what's in order, whether you can deliver. This is the world of business and money. Fourth, MES, Manufacturing Execution System. This is the shop floor world, the actual making of the thing, work orders, routing, operations, what was built by whom against which instructions. This is the world of execution and proof of build. So, ALM is intent and proof. PLM is the design truth. ERP is business and money. MES is execution. Four worlds, four owners, and here's what makes integration hard. The same real-world object shows up in all four wearing different clothes. A part is a requirement target in ALM, a designed component in PLM, a purchased item with a cost in ERP, a thing to be assembled on a route in MES. One object, four meanings. Connecting them isn't about wires, it's about meaning crossing boundaries without getting lost. Keep that in mind. It's the whole game. Now, the mistake almost everyone makes. They decide to integrate, and they think the goal is to connect everything to everything. Every system talking to every other system, data flowing freely in all directions. It sounds modern. It sounds like the digital thread. It's a disaster. Picture four systems. You draw a line between every pair, then between every submodule. You get a web of point-to-point connections. Nobody fully understands it. It breaks every time one system updates, and a small team can never maintain it. The field has a name for this: spaghetti integration. It's how companies end up with a connected mess that's worse than no integration at all. Because now the failures are invisible and tangled. Why does this happen? Two reasons. First, it feels thorough. We connected everything sounds responsible. Second, vendors are happy to sell you every connection. Each one is billable. But more connections is not more control. Past a point, more connections is less control. Because the complexity outruns your ability to govern it. The skill isn't maximizing connections, it's choosing the few that carry real value and refusing the rest. There is a standard built to stop the spaghetti. Every founder and tech lead in hardware should know it exists. ISA 95, also published internationally as IEC 62264. Don't switch off at the acronym. What it gives you is simple and powerful. A shared map of which system owns what, and where the boundaries between them sit. It organizes the stack into levels. The physical process and control at the bottom, the MES operations layer in the middle, the ERP business layer at the top. And it defines the boundary between them and what should cross it. Here is what matters for a small team. ISO 95 cares about one boundary above all, the line between MES and ERP. Execution on the shop floor and business planning in the office. That single boundary is where most integration pain lives and most audit risk. ERP plans production and accounts for it. MES executes production and proves it happened. ERP says, make 100 of this by Friday. MES says, here is what we made, from what, by whom, against which baseline. When that boundary is clean, execution is disciplined and your audits are defensible. When it's blurred, both systems think they own the same data, and you get endless reconciliation work. Your evidence gets weaker, not stronger. So the lesson from ISO 95 isn't buy this standard. It's a way of thinking. Integration is about clean boundaries and the specific information that crosses them. It's not about dissolving the boundaries so everything blurs together. Good fences, specific gates. That's the opposite of spaghetti. So if you don't connect everything, what do you connect? Here are the high-value links, the ones that carry real control across a boundary. Build this first. Link 1. ALM to PLM. Requirements to design. This is traceability crossing a boundary. Every design in PLM links back to the requirement in ALM that justifies it. This is the single most valuable link for certification. It's what lets you prove the product does what it was required to do. If you build one connection in your whole company, build this one. Link 2. PLM to ERP. The engineering bomb crosses into the business world. It becomes purchasing and cost reality. This is the E-bomb to M-bomb and supply chain transition we mapped in the deep dive. The value here isn't dumping the whole design into ERP. It's a controlled handover. Exactly the data ERP needs to source and cost the product, with a clear ownership of which system masters what. Link 3. ERP to MES. The boundary ISO 95 obsesses over. ERP sends the production order down. MES sends back what was actually built. This is the link that turns a plan into proof. Get it clean and your shop floor and your business finally tell the same story. Link 4. The one most companies forget. MES back to PLM and ALM. The as-built reality feeds back to the design and requirements worlds. What actually got built, what deviated, what failed. Without this link, your design world lives in a fantasy of how things should be built. and it is disconnected from how they actually are. The loop is what makes the whole thing a thread, not a one-way street. Notice the shape of these four links. They form a loop. Requirements to design, design to business, business to execution, and back to the requirements. That loop is the real digital thread, not a web. A loop. Four clean links across four boundaries, each carrying specific owned data. That's an integration a small team can actually build and maintain. Everything else you leave as a boundary on purpose. And now the half nobody teaches. What to deliberately not connect. A boundary you keep on purpose as a feature, not a failure. Three kinds of connections to refuse. 1. Don't connect two systems so both think they own the same data. This is the cardinal sin ISO 95 warns you about. Say ERP and MES both believe they master inventory. Now you have two versions of the truth and a permanent reconciliation headache. Every piece of data needs exactly one owning system, one master. Connections should move data across the boundary. Ownership stays put. Blur the ownership and you've built a machine for generating disagreement. 2. Don't build connections just because they'd be convenient. It'd be nice if this dashboard could also pull from that system. Maybe, but every connection is a permanent maintenance liability. It breaks when either system changes. A connection has to earn its place by carrying real control or real value, not mild convenience. Convenience connections are how spaghetti grows. One harmless looking strand at a time. 3. Don't connect worlds you haven't put in order internally. If your PLM data is a mess, connecting it to ERP just spreads the mess faster. Now both systems are wrong in sync. Get control inside the world first, the module to work. Then connect it. Integration amplifies whatever you feed it. Connect order and you scale order. Connect chaos and you scale chaos. Here is a test you can run on any proposed connection. Steal it for your next architecture meeting. 4 questions. 1. Does this connection carry real control or real value across a boundary? Traceability, a baseline, proof of build, or just convenience? 2. Is the data ownership crystal clear? Exactly one master. The connection moves data, it doesn't duplicate authority. 3. Are both worlds in order internally? So we are connecting order to order, not spreading chaos. 4. Can our team actually maintain this when one system changes? Because it will. Pass all 4, build it. Fail any, it's not a connection. It's a future mess asking politely to be let in. Found the takeaway. Integration is not a giant platform you buy to connect everything. It's a small number of deliberate decisions. 4 clean links that form a loop. Clear ownership of every piece of data, and the discipline to refuse connections that don't earn their place. Most of your integration value comes from getting 4 boundaries right, not from a £1,000,000 mega project. And like everything in this course, the tool doesn't decide your boundaries. You do. The tool just enforces them. Tackle takeaway. Your job is to defend the boundaries, to be the person who says, no, we will not let both systems own that data. And no, that convenience connection isn't worth the maintenance debt. The pressure will always be to add more connections. Each one looks helpful on its own. Your value is knowing which four matter and protecting the fences around the rest. Good fences specific gates. That's a connected operation a small team can actually run. So that's integration inside your own company. A loop of high-value links, clean boundaries, single ownership. But there is a harder version of this, connecting across organizations. When your design world has to exchange control data with a partner, a supplier, a prime contractor, a different company. Different systems, no shared master. That's where I've done some of my hardest integration work. And it's the next episode. Recap. There are four worlds. ALM is intent and proof. PLM is the design truth. ERP is business and money. MES is execution. The naive move is to connect everything and build spaghetti. More connections is less control. The skilled move is a loop of four high-value links: requirements to design, design to business, business to execution, execution back to design, with clean boundaries and one owner per piece of data. And also, you refuse three things: duplicate ownership, convenience connections, and connecting chaos. Run the four-question test before you wire anything. If this changed how you think about connecting your systems, subscribe. Next, we cross the company boundary. And in the comments, tell me which two of your systems currently both think they own the same data. That overlap is usually where your reconciliation pain is hiding.
Digital transformation time.
Two promises. If you're a founder, you'll see why cross-company work is where most of your traceability leaks out, and why fixing it is an advantage and not just a hygiene. If you're a tech lead, you'll get a concrete pattern for exchanging controlled data with another organization, and also the specific traps that make it fail. I led exactly this kind of work between an engineering company and a large international partner. We moved from a manual paper email mess to a controlled automated exchange. Lessons transfer directly whether your partner is a machine shop down the road or a multinational prime. Inside your company, you can declare a single master for every piece of data. One system owns the truth. Across the companies, that's gone. There is no shared master. You have your own version of the requirement, or the drawing, or the change. They have theirs. Two organizations, two sources of truth, and a boundary between them that no one fully controls. Everything heard about this flows from that one fact. And it compounds. Different systems, your PLM is not their PLM. Different processes, your change control is not their change control. Just remember how hard it's to negotiate between different departments. Different vocabularies, what you call a part, a revision, an approval may mean something different to them. Different security boundaries. You often can't and shouldn't give each other direct access to internal systems. So you're not connecting two systems, you're connecting two different worlds. They don't share a language, a master, or a trust boundary. That's why naive approaches fail. And when it's this hard, here's the default. You give up on control. You fall back to the lowest common denominator, email. Someone exports a drawing, attaches it to the email, sends it over. They reply with a markup version. A spreadsheet tracks who has what. A PDF gets printed, signed, scanned. It feels pragmatic. It's a disaster for control. Because now your traceability has a giant hole in it, exactly where two companies meet. Which is, by the way, exactly where certification and liability are most exposed. Remember the drift from Module 1. Across a company boundary, it's the default state, unless you actively fight it. Let me make this concrete with a real program. An engineering organization had to exchange requirements and technical documents with a large industrial partner on a regulated nuclear program. The starting point was the swamp I just described. Document transfers maintained by hand, data duplicated across systems, exchange happening over email, spreadsheets, and paper. And the consequence was exactly what you'd predict. Constant risk of someone working from a stale or unapproved version. Slow alignment, a brittle evidence trail, at the most sensitive boundary in the whole program. In a safety-critical context, that's not an efficiency problem. It's a control problem with real consequences. Here's what we did, and also the principle behind each of these moves. First, we stopped treating it as sending files. We started treating it as a defined exchange protocol, an agreed, explicit definition. What data crosses the boundary, in what form, when, and who's accountable on each side. The exchange became a controlled process, not an ad hoc favor. Second, we moved from manual handling to automated upload and exchange. And we've done it through a single hub. So exchanging stopped depending on someone remembering to attach the right version to the email. Third, we embedded integration between the engineering tools and that hub. So the data flowing across was connected to its source, not rekeyed by hand. The goal throughout, a controlled hub and exchange pattern instead of a tangle of manual person-to-person transfers. The result wasn't a tool deployment. It was an operational mechanism for keeping requirements and document baselines continuous across two organizations. The truth of what was agreed and what was current stopped living in someone's inbox. It started living in a controlled exchange. That's the difference between two companies hoping they're aligned and two companies that can prove they are. Here are the specific traps that sync cross-organization exchange. I've hit most of this myself. Each one has a defense. Trap 1. Version drift across the boundary. You update the document, they're still working from last month's. Across a company line with no shared master, this is the default. Unless you design against it. The defense. The exchange itself must carry version and status. Every object that crosses says clearly which baseline it is and whether it's approved. Never let a bare file cross without its identity attached. A file without its version and status is a rumor, not a record. Trap 2. Vocabulary mismatch. Your released is their approved. Your revision scheme isn't theirs. Meaning gets lost at the boundary. The same semantic problems we keep meeting, now across the companies. The defense? Agree a shared exchange vocabulary up front. A small, explicit mapping of the terms that cross the gate. You don't have to align your whole internal language. You have to align the handful of words that travel. Trap 3. Unclear accountability. Something crosses the boundary. Who's responsible for it? The sender or the receiver? If that's fuzzy, things fall in the gap. I thought you had it. The defense? Every exchange has a named owner on each side and an explicit handshake. Sent, received, acknowledged. The boundary is exactly where accountability evaporates. So that's where you make it most explicit. Trap 4. The convenience relapse. You build the controlled exchange, and then one day someone's in a hurry and just emails a file. to save time, this once. And the swamp creeps back, one exception at a time. The defense is cultural as much as technical. The controlled exchange has to be the easy path, not a bureaucratic hurdle people route around. If your secure exchange is slower than email, people will use email. Make the right way the fast way. Before you set up exchange with any partner, run these four questions. 1. Is there a defined exchange, a specific gate? Or are we about to default to email? 2. Does every object that crosses carry its version and approval status? So neither side ever works from a rumor. 3. Is ownership explicit on each side? Who's the master of what and who's accountable for each handoff? And 4. Is the controlled path the fast path? So nobody's tempted to route around it. 4 yeses and you have a controlled boundary. Any no and you have a future drift incident with a partner's name on it, which is the worst kind, because now the failure is shared and the liability is contested. Founder takeaway. Cross-company exchange is probably the biggest hidden hole in your traceability right now. And most companies never even look at it because email feels like it's working, but it isn't. It's hiding the risk. Closing that hole is more than just important. It's also a real advantage. A startup that can exchange controlled, traceable data cleanly with primes and suppliers is a partner big players actually trust. In regulated industries, that trust is a door opener. This is one of the places where getting the operating model right wins your business, not just audits. Tech lead takeaway. When you set up a partner exchange, your instinct should be clear. Define the gate. Never hand over the keys to your internals. Agree what crosses in what neutral form, with version and status attached, and with a named owner on each side. Then defend that exchange against the convenience relapse, because the swamp always tries to creep back. You're not building a connection, you're building a controlled border, a fence, gate, and customs, all explicit. So we've connected the worlds inside your company and now across company lines. But there's actually one more piece to it, and it makes all these integrations pay off in a way auditors love. When your systems and exchanges are properly connected, something valuable happens, and almost for free. The evidence you need for compliance starts generating itself as a byproduct of work flowing correctly instead of separate painful documentation exercise. And that's the next episode. It's where integrations stop to be an IT topic and becomes your certification superpower. Recap. Across organizations, there is no shared master, so integration is fundamentally harder. Different systems, processes, vocabularies, and trust boundaries. The default failure is collapsing into email and paper, which puts a hole in your traceability exactly where two companies meet. The fix is a controlled hub and exchange, a defined gate, neutral data, explicit ownership. Never direct access to each other's internals. Defend it against 4 traps: version drift, vocabulary mismatch, unclear accountability, and convenience relapse. If this showed you a hole you didn't know you had, subscribe. Next, how good integration generates your compliance evidence for free. And in the comments, be honest. How does your most important engineering data reach your biggest partner right now? Controlled exchange or somebody's email? The answer is usually uncomfortable.
Digital transformation time. Digital transformation time.
As always, 2 promises. If you're a founder, You'll stop seeing compliance as a cost center that slows you down. You'll start seeing audit readiness as something you can get almost for free if your operating model is right. If you're a tech lead, you'll understand how to design your connected systems so the evidence trail is automatic. So an audit becomes a query, not a fire drill. I built a digital environment behind a real aviation design organization approval with a tiny team. And the only reason that was possible is this. We made the evidence fall out of the work instead of staffing an army to produce it separately. That's the trick I want to give you. There are two completely different ways to be compliant. They feel similar from the outside, but they're worlds apart in cost and risk. The first is the bolt-on model, the common one. You do your engineering work in your systems. Compliance is a separate activity. And before an audit, a quality team goes around collecting all the evidence, screenshotting approvals, compiling spreadsheets, reconstructing who decided what and when. The evidence is assembled after the fact to satisfy the auditor. It's expensive, it needs dedicated people, it's slow, it's stressful. And worst of all, it's fragile. Because evidence reconstructed months later is partly archaeology and partly fiction. And in a small company, you simply can't afford the army that model assumes. But there is a second, which is the byproduct model. Here, evidence isn't collected, it's emitted. Every time work flows correctly through your connected systems, it leaves a trail automatically. A requirement is linked to a design. A change goes through the closed loop and records its own approval and timestamp. A baseline is frozen. A build executed in MES against that baseline. Nobody creates evidence. The evidence is just the honest record of work that already happened, captured as it happened. When the auditor arrives, you don't scramble, you query. The trail is already there because the system produced it as exhaust while doing its real job. Same compliance, same outcome. One model needs a department and produces fiction. The other needs a well-connected operating model and produces truth. The difference between them isn't how hard you people work. It's whether your systems are connected so the evidence has somewhere to accumulate. And why can't every company just do the byproduct model? Because it depends entirely on the integration work we did in this module. Evidence as exhaust only works if the trail is connected. Let me show you why. Compliance, at its core, asks one kind of question. Show me that this requirement was met. Trace it from the requirement, through the design, the change history, the build, to the proof. That question crosses every boundary we talked about. ALM, to PLM, to ERP, to MES. If those worlds aren't connected, if they're islands, then answering it means a human manually stitching the trail back together across disconnected systems. That's the bolt-on army. But if they're connected in the loop we built in episode 1 of this module, the trail already spans the boundaries. The auditor's question becomes a walk along a thread that already exists. Remember the loop from episode 3.1. Requirements to design, to business, to execution, and back. Picture it now with evidence accumulating at every link as workflows. The requirement to design link emits traceability. The change process emits approval records. The baseline emits a frozen reference. The MES execution emits proof of build. The same connections that make your operation efficient also make it self-documenting. That's the deep reason integration is worth the effort. It pays you twice, once in speed, once in evidence. Most people only ever see the first payment. There is a serious work behind this idea. The most relevant reference is recent research of assurance case-centric engineering, Wei and colleagues, in work they call Access. The core idea is exactly what we are describing. Your assurance case is your structured argument that the system is safe and correct. And it can be linked directly to the actual engineering artifacts and evaluated continuously as you build, rather than assembled at the end as a separate document. In plain terms, the proof is wired into the work and stays live instead of being written up afterwards as a story. That's the academic backbone of evidence as a byproduct. What I'm adding is the startup-sized version. You don't need a research platform. You need your four worlds connected so the trail is real and continuous. The principle is the same at any scale. Link the evidence to the work and keep it live. So, how do you design your connected systems so evidence falls out for free? 5 principles. None of them need a big team. They need you to decide this up front instead of bolting it on later. 1. Capture evidence at the moment of work, never after. When a decision is made, it's recorded then with its owner and timestamp as part of doing the work, not reconstructed later. This is the closed loop from Module 2 doing double duty. The same discipline that controls change also emits the approval record. If you ever find yourself gathering evidence as a separate task, that's the bolt-on model creeping back. Evidence should be a side effect, never a chore. 2. Link, don't copy. Evidence is only trustworthy if points to the live connected truth, not to a copied snapshot that can drift. When the requirement, the change, and the build are linked, the trail is self-consistent by construction. When they're copied into a compliance folder, you're back to reconstructed fiction. The links are the evidence. 3. Design the trail to be walkable in both directions. An auditor asks forwards the requirements, show me it was built and verified, and backwards, the part, why does it exist, what requirement justifies it. If your integration supports tracing both ways across the boundaries, any audit question becomes a query. This is the requirements traceability idea from the module 2, now spanning your whole connected loop. And 4. One source of truth per fact. The single ownership rule from Elia in this module. Evidence collapses the moment two systems disagree about the same fact, because now the auditor has caught you with two truths. Clean ownership isn't just tidy architecture. It's what makes your evidence credible. Contradiction is the fastest way to fail an audit, and duplicate ownership manufactures contradiction. And 5. Every meaningful object carries its own status and approval. A document, a baseline, a build record, it knows what it is and whether it's approved. This is the same discipline we needed for cross-org exchange in the last episode. And it means the evidence is self-describing. The auditor doesn't have to ask, is this the approved version? The object answers for itself. Let me ground this in something real, because it's easy to dismiss as theory. In a hydrogen electric aviation company, we had to operate as a certified design organization to earn what's called design organization approval from the aviation regulator. That approval is not granted for ambition or for paperwork. It's granted only if you can demonstrate one thing, that you operate in a controlled, repeatable, evidence-backed way. And we earned it with a tiny core team, which is only possible under the byproduct model. We didn't have an army to reconstruct evidence before audits. We had a connected environment where the evidence was a byproduct of how work already flowed. The digital environment and governance weren't a supporting act bolted on around the edges of certification. They were treated as an integral part of how the design organization operated. That's the whole thesis of this course validated by a regulator. Get the connected operating model right, and a small team can achieve what's supposed to do require a large one. Founder takeaway. Compliance is not a tax you pay separately at the end. In a properly connected operation, audit readiness is a byproduct of working correctly, which means you can be lean and certifiable at the same time. Stop budgeting for compliance as a dedicated army bolted on before audits. Start investing the money in the connected operating model, the one that emits evidence for free. One produces stress and fiction, the other produces a permanent, queryable truth. For a small company in a regulated market, this is the difference between certification being impossible and being routine. TechLead's takeaway: design for evidence from day one. Every connection you build should ask two things. Not just, does this move the right data, but does this leave a trustworthy trail? Capture at the moment. Link, don't copy. Keep the trail walkable both ways. One source per fact. Status travels with the object. Do that, and when the audit comes, you don't assemble anything. You run a query. You become the person who turned compliance from a fire drill into a side effect. That's a rare and valuable thing to be. And that closes Module 3. Pull it together. Integration is not connecting everything. It's a clean loop of high-value links inside your company with single ownership and deliberate boundaries. Across company lines, it's controlled exchange through a defined gate. Never direct access to internals. And when you get both right, you earn the prize. Compliance evidence as a byproduct of work flowing correctly instead of a separate, fragile, expensive project. Connected worlds, clean boundaries, self-documenting work. That's an operating model where a small team can move fast and prove everything, which is the entire promise of this course. Recap. There are two ways to be compliant. Bolt on, where you reconstruct evidence after the fact with an army, and byproduct, where the evidence is emitted as work flows through connected systems. The byproduct model is only possible because of integration. The same connections that make you fast make you self-documenting. Integrations pays twice. Design for it with 5 principles. Capture at the moment, link, don't copy, walkable both ways, one source per fact, and status travels with the object. A regulator approved a tiny team design organization on exactly this basis, so it's not theory. If this reframed compliance for you, subscribe. We keep building the operating model piece by piece. And in the comments, when your next audit comes, will you be assembling evidence or running a query? That honest answer tells you which model you're really on.
Digital transformation time. Digital transformation time.